close this here. Come on, close. Right. Oh yeah, it wasn't worth 10%. What did I write that on it for? Okay. So the first question, if you remember it, a boat sails 7 meters to the east and 9 meters to the north. What is the magnitude and direction of the boat's velocity vector? By the way, I misspelled sails. How should I have spelled this?
SAIL.
SAIL. Yeah. This is the noun, like shop sale. It's not this. It should be S. Yeah. Well, it's not this one. So of course, I think you understand what I meant. A boat sails 7 to the east and 9 meters per second to the north. Do you know how to do this one, or do you need me to do it?
No.
So, how do I get the magnitude? Pythagoras.
Yeah, Pythagoras.
Square root 49 plus, 7 squared plus 9 squared. And how do I get the angle? See, a lot of you
Use
forgot the angle.
I answered that.
Oh, I didn't say all of you. I said lots of you. Tan inverse what?
You just use trigo, and then I know you
Yeah,
can.
tan inverse what?
That over that. I had to draw it to.
No. East,
Okay.
no.
East and north. So and then
Tan inverse 9 over 7. Yeah? Yes? Goodness. I thought this one would be easy. So it goes 7 this way, 9 this way. So the angle is tan inverse 9. Yes. Okay. That's okay, yes? Yes? Yes. So number 2, the girl throws the ball up in the air and she's 1 meter tall. And she throws it up and it comes down and it hits the ground. The ground, not her hand. Okay. So what type of problem is this? UVATS, yeah. What's the U? No. 29. The V? No, we don't know. The A? Minus 9.81. The T? We don't know. We should find it, is it? Yeah. And the S?
it's plus.
We do know.
Yeah. It's -1. Yeah.
-1. Because yes. Goes up, and goes down. So just use one of the equations. I think we need to use S equals UT plus a half AT squared. This will give us the T. So this is fine, right? Give me smiles that you know this is okay, yes? Number 3, no problem. These are the 2 cars and they crash and they come together and they move away together. M1U1 plus M2U2. Now please, again, a lot of people made this mistake. They're moving in opposite directions. So that means this one has 18 and this one has -14. A lot of people forgot this. Opposite directions, not same direction. Yeah. I think I'll do number 4 with the moon and the planets, yes? So, if you want, you can write it down. You have a moon orbits a planet, and that's the distance the moon is from the planet, and it takes 28 days to orbit the planet. What's the acceleration? Let me just check how much more I have to do. And that was the end of section A. Okay, so when you look back on it, you should think, Oh, that was kind of easy, right? No?
Not number 4.
Except maybe number 4. Continue.
No.
Oh my goodness. Yes? Okay.
The head is in the moon.
Moon orbits planet. So it's like this. Here's the planet, and here's the moon, and it's going around like that. The distance is 342,000 kilometers. So here the radius is 342,000,000. Did you forget the K?
No.
No?
I
Oh, you
misunderstood.
didn't understand. Okay, fine. And the time it takes is 28 days, which is in seconds. 28 times 24 times 3,600. 2419200 seconds. And you want the acceleration. So if you look in the formula book, what type of motion is this? Circular motion. Does anyone remember the formula for the acceleration? You have two formulas. It's v squared over r, or the other one is yeah, but there's a minus in it. I won't worry about that. The minus is this way. V squared over r, or omega squared r. Which one should I use?
Both.
No. Which?
Omega?
Yeah, this one. I need to use this one because I could say the acceleration. Do you remember there's another formula? T equals that, but 2 pi over omega. So that means the omega is 2 pi over t squared times r. Do you know the t? Yes. Do you know the r? Yes. So we have the answer. Hey, just be finished in a second. Now the answer is actually quite small, and in fact it should be quite small. Meters per second squared. And the reason it's quite small is because when a planet is moving in a circular path, okay, the easiest way for me to explain this is the harder the circle, the bigger the acceleration towards the center. So for example, if I have a car and it turns really fast, then there's lots of acceleration to the center if it turns really fast. But imagine the car turns very slowly in a big circle. The acceleration to the center is smaller. Picture the planet going around, the moon going around the planet. Is that a hard turn or an easy turn?
Easy turn.
Very easy, because look, I'm sitting here, the Earth is going around the sun, and I don't feel it. But if you were in a car going around a corner, you would feel it. We don't feel ourselves moving in a circle. That's because this is so small. This is normal for planets and moons. Okay? But this is actually not small enough that you couldn't measure it. So if you had a very good instrument, you could actually measure numbers this small, but we can't feel them. Yeah? Okay. Section B.
Section B.
Section B was this.
Very easy.
It was quite easy. A lot of people though had trouble expressing Newton's three laws. So what is the first
Also,
law?
other trouble
What's the first law?
graph of
What's the first law?
Newton's first law is
Newton's
inertia.
is what?
Inertia.
Yeah, no, but give it to me in a sentence.
The tendency of an object to remain in motion or remain at rest unless acted on an external force.
That's it. That's the first one. What's the second one?
Newton's second law is
F equals ma. Very good. Force is a product of mass and acceleration. And Newton's third law is this one.
yeah.
Oh,
Every action has a equal and opposite
every
reaction.
action has an equal and opposite reaction. So
What
6 marks.
did mine have this?
Huh? I don't remember. It's so long ago. And then part 2 is the graph. So it starts at 9, not 0. Starts at 9. It accelerates for 1 second, then constant speed for 5 seconds, and then decelerates to rest. So the graph doesn't start at 0, look, it started here. So if you remember your graph should go up,
Yeah.
across, and then down. And part C, how do you use this graph to get the distance traveled? It's the area here. And lastly, the force ma. So you need the a. How do you get the a at the end?
The
Slope.
radius.
Yeah. I thought this was an easy mid-semester exam, don't you?
No.
No?
Right now.
Right now it feels easy.
If the question is easy, we can get 100.
I thought maybe you could get 100 in this. No?
Just the first one, definition.
Yeah, so let me tell you for the exam the definitions you need. Newton's three laws, of course. And what about in electricity? What are the definitions you need, or the laws? No, electricity. Kirchhoff's two laws. And are there any definitions in waves you might need?
Definition of wavelength.
No?
Refraction, refraction.
No? Maybe like the two types of waves.
Yeah.
The longitudinal or the transverse.
And the longest, I forget the name.
The longest?
Very long.
Very long?
Longitudinal and transverse wave.
Longest? What are you talking about?
No.
Longest. Wave?
Definition.
Definition?
I'm checking.
Path difference?
Maybe. I forget. Okay, never mind. Forget it.
Perfect. So there will be some definitions in your exam next week, but mostly it's calculation, like your mid-semester exam. Okay? So you have 3 questions in section B, in mechanics, there's an example there, in electricity, so what will be a long electricity question? Kirchhoff or a graph. Yeah? And then waves, the question I did today is an example of a section B wave question. Yeah? So something like this you might get in the exam.
In section B.
In section B. In section A the wave question would be much shorter, like yes. Now? No, later. I'm having lunch now. I'm hungry. Very, very hungry. Very, very hungry. Okay. When's our test next week? It's next week, isn't it?